Hello, this is from Vijayakumar, Assistant Professor, Department of Physics, SNS College of Engineering. I am taking the topic of crystal physics in another one topic, following of crystal physics, the growth of single crystal melt growth technique to the form of Czochralski method. The previous video we discussed in Bridgman method, it's a oldest method. This is becoming a Czochralski method. So the same form already we discussed from this, the crystal, three phases, solid, solid, liquid, solid and gas solid, especially to the form of melt. The melt is form of Czochralski method. So the one of the major melt growth technique is a widely used to growing large single crystal. That is a small, this is becomes a large. So that is a difference between Bridgman and Czochralski. For a wide range of commercial and technological applications, one of the main advantages of Czochralski method is a relatively high growth rate of the crystals. So this is a block diagram to the form of crucibles. So the rotating motor, rotor and stator to the form of opposite directions. So the molten state to be rotated in inside, and the pulling rate based the crystal growth will be formed. So the crystal growth is high from this method. So the centrifugal force is act of the molten liquid is maintained to the form of the electric furnace in outside of the coil. So maintain the temperature. So the surface tension and the temperature, it's act of the Lorentz force and biologists. So the material to be grown in the first melted by induction or resistance heating coil under the control of atmospheric in a non-reacting crucibles. So it's a very important because it's a form of some contamination to the reactor of atmosphere. The crystal growth rate will be changed. So the melting point and the temperature is maintained from the crucible. The freezing point is judged by the cooling the melt until crystals start to appear on the surface. After the further lowering of the temperature, a seed is injected in the melt. The pulling and rotating the seed simultaneously, the crystallization center to the forming. The diameter of the pulled crystal is converted by manipulating the temperature of the melt and the pulling rate. So the axial and radial temperature gradient is needed to grow single crystal of desired dimensions reliability. So the important factor we followed from this method, the one is pulling rate of the crystal, the temperature gradient of the crystal, then third one is temperature of the melt. So the pulling rate is changed, the crystal nature will be changed because the pulling rate wise the crystal growth is formed, and the crystal growth wise the crystal imperfection is formed in that the crystals. So based on that the pulling rate, the quality of the crystal will be created. The next one, the temperature gradient. The temperature, it's a form of certain range to maintain in the crucibles. The purity of the crystal is forming. The temperature will be varied, it's change of the quality and also to the growth of the crystals. The third one, temperature of the melt is very important because the freezing point and melting point, it will be changed in the liquid phases. It's a change of growth rate. So this three is a very important factor to be affecting and to the form of advantages. So the large diameter of the crystal as 10 centimeter or more can be obtained within a more crystal growth rate. So this is to the one of the best advantages from in a Czochralski. Then second one, crystal with desired orientations. So all the area to the form of exact surface layer to the form of crystal growth. Then third one is a crystal growth adjustment in temperature and growing rate is made to its form of needed. And the last one is dopant uniformly to be formed in that. The next one, disadvantages, more defect and stresses are induced. That way I am telling that the pulling rate of that crystal is a form of this disadvantages. So this is a reference I prepared from this PPT. Thank you very much. We discussed in another one topic to the form of crystal physics. Thank you.